Hello everyone, I am Hegde Nikhil Suresh. So this is my repository as you can see, and today the focus is on M3, that is the module 3 Viper control system that has been designed. So let's jump in. So yes, so these are the contents of our repository. So first, so we'll see, you can see here the Viper control that system that is designed here. The objective of this project is we have to initiate automatic Viper action without any manual or human intervention by sensing the intensity of it. Can be anything, it can be rain, can be snow, or it can be dust, and thus based on that, whatever the input that has been received from the sensing unit, we are either increasing or decreasing the Viper speed accordingly. So this automatic Viper system, it has a sensing unit and it has a controller that is of which is designed using STM32F407VG Microcontroller and a motor unit which moves the arm of the Viper. So yes, so let's see exactly how is it working. So just jump into here. So this is nothing but WSL, is Windows Subsystem or Linux. Ubuntu is installed here, and I'm right there inside the folder where my .elf file is there. You can see here, I have my .elf file over here, and yes, so now we'll run the command to execute the project. So here you can see a window pops up. So this is nothing but a ST discovery kit. So this is like an emulator, we can sense it without having an actual hardware. We can work on it, the basic one. So based on a project, if I press the first button, this is how my system starts. That is the very first requirement of the project, that is the ignition on, the system on. So second is that if I want a Viper control, let's say here I am pressing the button, but in really this is nothing but what one can say is that a sensing unit, a input received from the sensing unit. Say there is rain that is coming. So this is the first level. So you can see here LEDs are blinking. This is going like this from here and back to here. So this is the same as a Viper action. You can see here the output. Now let's say the intensity is more. So let's say when I press the second time, so see the speed increases. So first it was at 1 Hertz, the frequency, the design requirement based on the given design requirement, it was 1 Hertz. Now it is 4 Hertz. Now if we if there is a rigorous rain or something like that, so we need even more faster action to clean up those things so that the visibility is not compromised at the driver's end. So we see the next thing, if I press again, so see this is way too fast, that is 8 Hertz. So when I press this button again, so let's on off the system, so this is how my system is on, off, and this is how I can turn it on, and all those things I can repeat. So this was all about a little part of the demo about the working of the project. So next coming to the part of requirement, here we can see that this is again as described. So the features is it can control the Viper action as you have seen in the output. We can change it, we can initiate it. It's an automatic control by sensing unit. We can change it. So here the driver's attraction is not driver's attention, is not diverted. So what happens is that this is very normal, in that case the accidents can be avoided. So it's reliable and easy to confer, and then you have seen definitely, so we have put the 3 different modes of control, that is the low speed 1 Hertz, medium speed 4 Hertz, and high speed, that is 8 Hertz. So here it will be more clear. These are the higher level requirement, that is red LED should be on to indicate the ignition key position. Second is the LED come on saying the desired pattern, a wiping action, half clockwise, half anti, it's something like a wiping action. And next is to turn off. So if I see the low level requirement, especially of this one, so what are the set frequency? When I talked about, we use 3 different types of frequency. So that that means I'm talking about the speed, how much it should wipe, how fast it should be. It can be 1 Hertz, 4 Hertz. So those are all implemented, and this is the SWOT analysis of the project. So that these are the strength, control available, strengths are all those whatever you have seen as a features, this is the strength. But what is the weaknesses? One thing is that one of the requirement is still pending for implementation. The differentiation between the button press and the ignition on and speed control is not very clearly specified. And there are many additional features in the real life scenario. If you see, there are water spray, or it can be a shampoo holder. There are many things or it can be rear, right, rear wiper. So there are many additional integration features. This controller at this moment, right, cannot support that. So that is the weakness. And what are the weakness? As usual, those are nothing but the opportunities. So these are, it can by utilizing the input capture method of the timer, definitely we can differentiate it, and that can be easily resolved. Second is complete end-to-end solution can be obtained, right, if you work on those integration problems. Now what is the threat? So definitely the system is not waterproof, fireproof. Definitely it should be, because we don't know, right? In such cases it should be. Second is a sensor module unit or motor control unit. Let's say if it fails, right? So then we don't have anything to assert that, right? For example, when I put the key at the ACC position, if there is a system, right, which says that okay, the sensor unit is not working, so that I realize only when, right, the rain comes or something happens, so in the midway. So that is a little threat, right? So that is a great amount of threat, I can say that. So that unit could be, right, if it's a threat, it's not there. So 4Ws and H1H, you can see here what. So definitely it's an automatic wiper control system. It is using the microcontroller, this one. When you are using it, when the visibility of road is compromised due to many reasons, it can be rain, snow or dust, where you are using, definitely it is placed on, it's a wiper, it's placed on the windshield of the vehicle. Why we are using it? To improve the visibility, to prevent accidents, and to, right, just ensure safe travel, that's all. How we are using it? We are, right, taking this as a microcontroller STM32F407 as a embedded system controller here, right, for that wiper arm action. It's a motor controller right here, especially just like basic, if I say that it's a motor controller, but in the whole system I can say that it is controlling that wiper arm action. So these are some of the references. Now going back, right, to the design part of it, we can see here, right, you have the architecture. So this is the architecture, this is my controller end, this is the input, that is the button here, but normally this is button is assumed, normally it is input from the sensing unit, and another one is for the control, if you want to control it. So this is from the user end. Now if you see the output, this is red LED, ignition on, and also, right, ignition off, right, if it goes off, so that means ignition on and off. So these are three, right, which represent, because see, we can't we haven't have it, this is all being virtualized, right, it's a prototype. So in the prototype stage, I can say that as a proof of concept, this is like blue LED, I say that it represents left position, green LED as a middle, and orange as right. So this is how it sweeps and it comes back, as you might have seen, right, in the output, that the emulator output that we just saw, right, between. So this is how it is. This is the flowchart. So definitely how the code actually is formalized, it starts, it includes all the necessary file, initialization is done, GPI initialization is very important, is done. Flag we are using just to indicate different stages. Okay, so while one. So this we are checking for whether there is an interrupt. Interrupt means if button is pressed, so then the flag will get incremented, right? So if flag is 1, definitely that's the first step on. Or flag is 2, that is you have to alternate, you have to blink, right, orange LED at 1 Hertz. Here you have to blink at 4 Hertz. Here you have to blink at 8 Hertz. And flag 5, it is off if it is more than that. Let's say it is flag is 6. I'm reverting it back to that position, because as we have seen that the differentiation is still a small problem here. So but to ensure the continuity of the code, I did this so that it gets reverted back to the reset position at the very first position. So this is the schematic diagram. As you can see, this is for the like push button, right? This is the variant. Okay, this is how the input comes out, having the voltage divider here, and these are the different LEDs, how the LED interfacing is done as an output here. So this is the power up, this is how it powers, and this is the ground. So this is all about, right, the design aspects of it. And right, coming back, going to the implementation, and you can see here, you can explore this folder here. Actually in the core, in the source, right, we have all the C files, .c files we have all, right. It is the main .c file where I have written the logic, right, and yes, these are the configuration file .c file. These are the function. What are the function that we have used? So definitely I used a multi-file approach. So here also you can see that you have header files inc, where it includes all the header files, and the configuration header file, function header files, main header files, everything is there inside over here. And these are all other parts. If we come back, right, you can see there are many files over here. These are for the debug settings, drivers and all, right, STM and all. So you can write directly, you can clone this one and you can run it in your STM cube ID, right? So it will work really fine, or anywhere in the terminal maybe. So this is how it is, all the implementation part. And coming to the test cases part of it, right, testing definitely we have done, right, we shouldn't compromise on that. So first button here we expected, right, at ACC it should be on. Yes, it is on. Second button, it should, the right LED should come in a say certain desired pattern or frequency of 1 Hz. Yes, it is met, that objective is met. Third press, right, it should be at 4 Hz, that is medium speed. Yes, even that objective is also met. Fourth button press, again the LED, it should be at 8 Hz, again even that objective is also met. And the fifth button press, it should be off, red LED should be off. So yes, so all the test cases are working very fine, you can say that. So here is, you have the output file, so that is, you have the .elf file, you can just hit and you can emulate it, right, if you want to see the output. And here is the emulator output. So that's all, right, everything that sums up, I think, every part of this repository. So if there is, right, if there is any queries or suggestions that you feel, right, should make or should enhance the project, or say Nikhil here, you could make this more better, so please feel free to reach out to me at this email ID. Okay, thank you everyone.